Okay, hi everybody. We are gonna try to make a video about a process I use to make panels for Phoenix A320, but basically you can use the same principle for any other plane or panel or whatever. First of all, I'm sorry for the video quality or sound quality for that matter. I don't have any recording equipment, so I'm just using my phone, but it should work, I hope. Also, as you can tell, I'm not a native English speaker, so I hope everybody can understand what I'm trying to say. So basically, we are gonna try to build, we're not gonna build any particular panel, we are gonna try to build like a hybrid panel of sorts so that we can show the different type of switches and how they work. But again, you can just translate that to whatever panel you are making. What do we need? We need you need a soldering iron. It doesn't have to be a fancy one. Any iron should do the trick. Cheap one, expensive one, it doesn't matter. You need something to cut your wires. You need something to strip your wires. Again, it doesn't have to be this thing. You can basically use, I don't know, for stripping you can use a lighter or a scalpel or whatever you have available for you. It's not that difficult to strip a wire, but this just makes it a bit faster and cleaner. We need, what do we need? We need an Arduino board. This here is Arduino Uno, but you can also use Mega or Nano. Actually, Nano is a bit small. But the point is, the whole thing works through Arduino boards and with MobiFlight software, which is free. So we're gonna get to that part later. You need some wire. It doesn't have to be 17 different colors. It can only be one color, just as long as you follow the line properly and know which wire goes where. You're gonna need switches, of course, different types of them, but again, we are gonna get to that part as we move along, and I believe that's it. I'm using this is an old piece of MDF 5mm board. You can go thicker, maybe 8 or 10 to help the sturdiness, but for me this is good enough. You're gonna need a home printer, a regular home printer. I think I'm using like 30 euros HP one, and some glossy paper. This is a glossy photo paper. It's a bit thicker than the regular one, and it, how do you say it, presents the color better. But again, you can use the normal one, but this one is better, at least for me. And I think we covered it all. That's all you need. I'm gonna, how do you say it? These are the panel faces I made in Photoshop, but you can use any other program like Corel or whatever you are good with. It's just a simple drawing, nothing special. I'm gonna put all of the files in Photoshop in description, and I didn't merge the layers, so you can change the, how do you say it, the diameter of these holes, radius, because, for example, I made these according to the switches I had. This is like 12mm for this particular switch, because this switch body is 12mm, but you can again change the diameter according to the switches you have, because, for example, this one is much smaller. I think 6 or maybe something like that. And then you can, this is for your, like an engine panel starting thing, and this is a TCAS panel. Again, you can do whatever you like. You can change it accordingly to your needs. For example, I have put these two switches here are for the weather radar, but I think now, since the last update, Phoenix did something with the weather radar, so maybe you want to make a whole new panel for it. So you want to remove these things or whatever, it's up to you. So to begin with, doesn't really matter. Again, we are gonna make a hybrid. It's not gonna be any panel in particular. We are gonna cut this thing. Yeah, again, when you cut it, try to, I made a mistake here because try to leave a bit more space around the switches, because when you try, when you're gonna mount it on your pedestal or whatever you made, like custom holding point, for example, here on this side, the switches are gonna stand like this, for example, and they're gonna be very close to the edge, so you won't have enough space for the holes. I forgot to calculate that part in. So when if you copy my design and if you use this particular thing, just leave a bit more space around here so that you can drill the hole for later for the screw to go through the panel for the mounting part. So we have the panel, let's say. This is an MDF board. Again, we are not trying to make this pretty, we are just trying to show how it works. So I just used regular instant glue. Another thing why the photo paper, the glossy paper is better, because it's thicker, the glue won't go through. Because if you use the regular paper, I think the glue is gonna, how do you say it, go through the other side. This is just some activator. Okay, relax. And just simply glue it like this. Give it a second to set. Then we are gonna drill the holes. Again, I made these according to the switches I had, but you're gonna do it with your own. You're gonna know how big of a hole you need to drill. So for example, I know that this is 12 millimeter and this is, I believe, 8. Yes. So you need a 12 millimeter and 8 millimeter drill bit. Try to put something underneath, because otherwise if you drill through, this thing is very, how do you say it, thin, and it tends to explode on the other side. So try to have something underneath when you drill. I'm gonna put yeah, one other thing I forgot to mention, don't do it like this straight away, because as you can see, I teared up the paper all around the hole. So try to, before drilling, get a scalpel or something and try to cut out the holes, so that you don't tear up the panel face. If you want to make it pretty, again, tidiness and pretty is not my stronger suit, so you already probably noticed that the ones I made are quite terrible looking. But if you have the patience and the time, you can make it much nicer. And cutting out the holes pre-drill, it's gonna help prevent the drill bit to tear up the paper while drilling. Also, another advantage of the glossy paper, it's much stronger and sturdier than the regular paper, so it's not gonna tear that much. For this one here, we're gonna make it a bit bigger for a different type of switch. We're not gonna put the rocker switch here, even though it's supposed to go, but again, we are just trying to cover a lot of different type of switches, so that you can know if you're, for example, making an overhead panel or a, I don't know, auto brake panel or whatever. The principle is the same and it all works the same. So let's see, here you have a 16mm switch. And these here are 12mm. For this one here, we are gonna wait a bit before we decide what we are gonna put on it. Okay, so let's say this is your panel you're planning to build, and now you have to decide which switches you're gonna use. So there is a lot of different types of switches you can use. I mostly use like 1, 2, 3, 4, 5 types of switches. This is a 3-way rocker switch. This is a 2-way. For example, this you can use this for your lights on the overhead panel, or for example here on the weather radar you have position 1, off, and 2. This is a 2-way switch, the same thing, but just 2 positions. You can use it here, for example, for your master engine on and off, or your lights or whatever. This is a momentary push button. I use this for, you can use it, for example, for call on your overhead panel for your cabin crew, if you're using, what it's called, I forgot the app name, but it doesn't matter, you know what I mean. This is also a momentary push button. I use these for the number pads on your TCAS panel, so you have numbers 1, 2, 3, 4, 5, 6, 7, and no, 0 till 7, yes, and a clear button. So I use these here. How I made this thing work, it's a bit of a, how do you say it? I took a part of, this is like a prototype board. It's a very cheap thing, it costs like 50 cents a piece. So I think this is the one I used to cut. I made a piece of the board here that I cut to size, and these things fit through these holes perfectly, so you can push as many buttons as you need. In this case 9 through these holes, and that's how I mounted the buttons to my panel, because I couldn't find another way, because for example these things, they screw on to the panel very easily, so there's no problem, you can do it. But for these things there's no mounting option, so I made a piece of prototype board and I placed 9 of these buttons, one side by side like this, Okay, this one didn't really fit well, but you understand what I mean. So I made like 9 buttons like this, and they also come with these caps that you can just put on top. So that's how I made the numpad here. Then I just took some M3 screws, and on 4 ends I screwed them to the panel face I had already before. So where did we stop? This is a switch I use mostly on the overhead panel because it resembles the Airbus type of switches the most for me, and it's a self-latching button, so if you press it, it stays in the locked position. And this is the 12 position rotary switch. This is just a random cap I use because otherwise these are very difficult to turn. It's a standard 12-way rotary switch. It has 12 positions. Of course, you don't need all of them. You just need, for example, here you just need 3: crank, normal, or start ignition. To find which is your position 1, there is usually a small thingy here that's telling you which pin is your position 1 pin, because you have to wire only the pins that you're gonna use. This thing here in the middle, you see a pin in the middle of the circle, that's your ground or common, and there is 12 corresponding positions. Normally this thing here, the black thing of the top, is telling you that this one here should be your position 1, so then 2, 3, 4, 5, 6. But if you're not sure, you can always use a multimeter. It's a very handy thing, it's not expensive. Put it to resistance measurement. It's a little ohm symbol here. This is ohm, it's a resistance symbol. You put one of your pins to the ground, and then the red one should go here. So you know that this is your position 1. If you switch the panel to the next position, this is your position 2. Next position, this is your position 3. So that's how you know which positions you need to wire and to make your switch work. So you see the thingy here. This is your position 1, so next one to the right in this case. We can maybe use something to mark it for future reference. Also, to prevent, because in this case you can turn the switch 12 times, you don't want that, you only want 3. There's always a little thingy that comes with the package of the switch. It has like this pin, and on the top side of the switch you see here there are 12 holes and there are numbers next to it. I don't know if you can see on this camera, it's very shit, but that's all we have. So you put the pin to the number according to the number of positions you need. In this case we need 3, so we're gonna put it on number 3, and you just press it inwards. So now it should only have, this is 1, 2, 3, 3, 2, 1, and it won't go any further because this pin here is preventing it from moving. So you only have 3 positions on this switch now. Okay, so let's mount a couple of switches and then we can do the wiring process. The wiring process is always basically the same. You have your ground pin on every switch, your ground line, and you have your input wire that goes to your Arduino. So regardless of, for example, this switch only has two, so it's very easy. One is ground, one goes to digital input. For example, this one has three, so one is again the ground, and the two positions are the ones you need. Ground is always your off position, and then you have, for example, on your nose wheel lights, you have, I don't know, what is it, taxi and takeoff positions. On this thing here, it's a bit different because it has, disregard these two pins on the side, these are for the LED. This is a switch with a LED in it. So for example, let's try to make 5 volts. This is, let's say, 5 volts. So if you put 5 volts to it, it's gonna light up. You can also use it with Arduino, but that's a different subject. We can maybe cover it later when we get to MobiFlight part. But for this part, let's say you don't have these two pins on the out, you just look at the 3 in. So you have, I don't know if you can see it on the camera, there is a C button, that's your common or ground. NO means normally open, and NC means normally closed. Normally open means that the function, the switch, is going to work when you press it. Normally closed means the opposite. It's going to work, it's going to be constantly on until you press it. So if we connect our multimeter again to, one goes to normally to ground, or the common, try not to touch these things. So this is a normally open. When you press it, it's gonna work. If you put it on normally closed, it's gonna work all the time until you press it. So basically what you need in most cases, or what I used, is this middle pin. So you wire the C and NO, just the two. You don't have to wire NC or the LED pins. But we are gonna get to that part later. So we are gonna put one of these things, 3-way switch, a 2-way switch, you need a key number 15 for this. Try to be as careful as possible because, again, it's just a paper. If you scratch it too much, it's gonna leave a mark on your panel. If you can find a better way to tighten these things, please do. I couldn't, so this is how I did it. Okay, we're gonna put one of these. And you have this black thing, you just tighten it from the opposite side. And on this thing we can use, I don't know, this one. I don't know how big this is. 15. Yeah, I think we can use this. As you can see, I didn't cut the hole around the switch properly, so I teared up the paper, so try not to do that. But again, this is just for the showcase, doesn't really matter. Okay, and this thing here, for some reason it doesn't want to go. I think we need a bigger drill bit. I'm gonna cut off this thingy here because then if you don't, it's gonna make your switch a bit tilted. Again, you always get these bolts and nuts and everything you need to secure the switch properly. For these caps, sometimes they come with the switch, mostly not. You can buy them on AliExpress or Temu or eBay or wherever you are cheaply. Basically, all of these switches are from AliExpress, Temu or something like that. So they're very cheap. I'm gonna put all the links in the description. These things you can also buy there. I think for mine, because I needed something bigger and I liked it to be something bigger, I think I literally used a knob from how do you say it? It's from a kitchen stove, but you can use whatever you want. Okay, so let's say this is our knob. Also, one tip: try to plan ahead and buy all the switches and everything you need in one go, because otherwise you're gonna have to pay for the shipping, and usually, actually always, the shipping costs much more than the switch itself. And also about these things, the Arduinos, try not to buy them from the sources I mentioned before, because usually they tend to put the wrong chips, the older chips, the connections are wrong. It's not gonna work. Mostly it's not gonna work. So try to buy them from like a certified dealer, like AZ Delivery in Germany or Elgato or something like that. Or maybe buy them directly from MobiFlight site. That's the best option. They cost around 20 euros a board, depending on which one you want. And the ones from Chinese options are like 10. So if it costs 10 euros, it's not gonna work. So try not to go cheap on these things. Okay, so let's say we have our panel here. Let's turn on our soldering iron. Give it a moment to warm up. The wiring, I didn't make any wiring diagrams. I went with the flow. You can do however you like, but the general idea, you're not gonna make it, how do you say it, complicated. You have to close the circle, so you have to have your ground and your digital input. Again, positions you want to be off, that's your ground. And then you have, depending on a switch, you have 2 or 3, how do you say it, digital inputs or commands that you want to put on your MobiFlight later on. So what you can do with the grounds, you can daisy chain them, as they say, or connect them all together. So for example, this is your ground. From here you wire it to here, to C button, to this ground, then you wire it to here in the middle, to this ground, then you wire it to here, and then to here, all together. So all in one chain of grounds, and then one last wire is gonna go on your ground pin on your Arduino. So this Uno, it has GND, that's your ground. So 1, 2, 3 grounds on this panel. So even if you want to make it a separate connection, you can't. You only you need like 5 for this one, and you only have 3. Megas have more, but it's always better to save space, and it's easier that way. So you just connect first all the grounds together. We're gonna use this wire. The wire can be whatever you want, from 16 to 22 AVG, doesn't matter. But if you go too thin, then it's gonna easily break. So try to go around 18, 20, I don't know, something like that. So you strip the wire first. Again, you don't have to use this thing. You can use a scalpel or a lighter to strip the wire. Although it's much easier with this thing. That's my multimeter. So what I like to do, maybe try to get one of these things, like some sort of helping hands or something. This thing costs like, I think, €1, but it's very handy because it's gonna hold your wire when you solder it. So I always try to put some solder on the wire first to improve the how do you say it? Also, you see here, I don't know how good can you see on this camera because it's quite shit, but we are gonna do our best to show it. There is like this little hole. Maybe the easier way would be, you can do it multiple ways, but maybe the easier way would be to fill the hole with solder, like this. And then just on the second go, you just simply take the wire. This one is too short, so we're gonna use this for another thing. So you always put the iron on the surface you want to solder, so you basically warm it up, and then you apply the solder to that same, how do you say it, area. Eh? Okay, so that's once we need to fill in the holes, so you can see now the solder is in the hole. For this one here, for this one, you don't have to solder it. You can just, if I can find my screwdriver, you can unscrew the bolts here, and then you can just wrap the wire around the bolt and then just tighten it to make a good contact. Also, sorry for my hands, I have this condition for the trembling, ignore it. So, where is my, yeah. So let's say from here to here. So let's say on this switch, and basically most of them, it doesn't really matter which one you choose to be your ground, it's the same thing, but one has to be ground and the other one has to be input. So let's say we're gonna put this one to be our ground. So we warm up the solder, the same area. Wait a second. And you just drive the wire through that and let it set for a second, and there you go. You got it soldered. Here on this one, there is a C, you just yeah, one other thing that you should maybe do, but it's not, how do you say it, necessary, it's gonna work either way, but it's gonna help to prevent to maintain the contact better and prevent later issues, is these things. They are also very cheap. These are just like isolation sleeves, but you should do that before you, how do you say it, weld it or solder it, because otherwise you won't be able to put it on. Okay, this is literally the worst position it could go to. Although for this one I need a thicker one. This one should be okay. So you put the sleeve here, and this is for the other side. Again, you can do this with a lighter. You just need to shrink the sleeve so it's some heat, it's gonna shrink up, and there you have it. Now you have your contact isolated and protected. And for the other side, we first need to put the sleeve, and then we have to you need a lot of patience for this. This thing also dances around, so I have to. And there you have it. Although wait, I need another before I do this. So these things are now daisy chained, so now we can put one wire here and the other end on this thing here, the rotary switch. But as you can see, it has a kind of a different type of switch, so you don't have a hole to fill. You're gonna have to, how do you say it, connect it physically, or maybe you can use these things. I'm gonna put a link for these two things too. These are jumper cables, also cheap and very, very handy. I don't know why are these so long, but it doesn't matter. These are male female type. There's also female female or male male, so they go, this one should go to your, for example, let's say this thing, the female part can go on this switch here, and the male part goes to your Arduino. Doesn't matter, like let's say pin number 10. So that's the end product when we are all finished, in theory. But since we need to, we can use these are very good for, like, for example, for when we are finished, for our how do you say it, digital input parts. For our ground parts, we have to connect them to each other. So now in this particular case, one more wire has to go through this ground to here, or it doesn't matter, to here, but it has to have two wires on them, so we can't use the jumper cables. Again, when you use this technique with the hole in it, and you just have to melt the solder so you can put the wire through it. You don't have to put any solder on your wire, but for this type of switch and this type of soldering, you need to put some solder either on this switch or on your wire, and then on the second go, when you try to solder it, you just melt the one you already have and let it set, and that's it. Because otherwise, if you try to do like with in one hand you have your soldering iron, other hand you have your wire, you need a third hand to hold this thing. It's just impossible, you can't do it. So just try to put some solder pre-operation either on your wire or on your switch, so that you can just melt it in the second go, let it set, and that's it. Okay. And there you go. Now it's soldered. If you have some, I have a device, it's in my, it doesn't matter, that can hold this thing. It's much easier because otherwise you can tell it's dancing all around. Also, I forgot to to put my sleeve here, so it doesn't matter. But if you want to do it, you always have to do it pre-soldering, because otherwise you won't be able to. So that's it. Next one. something weird. I can't find where the hole is. The hole is very small. And then one from here to here. And now for this one, so you just need to wrap this wire around the bolt and then tighten it so you can make the contact. I honestly don't see it. So just like this, now it's tight. And then you need one more wire, or your last wire, that goes from this thing, from this ground or any other ground, whichever you want, to your Arduino. So for that part we can use this thing, although we are gonna cut this plastic thing off. We don't need that. some reason this is very different type of material. My tip is very fucked up. Okay, and that's it. That's your ground connected. Here's my wire. So we need this. And this. And this. Again, you can also solder these to make it a much stronger and better, how do you say it, connection, because this way it can go, but it's quite safe. But also you can do it like this, it's much easier, at least for me. So this one is okay. I don't know what material this connector is, but this is very fucked up. It did come with this thing here, so normally it should go on top of it. So if you put the wire through here. Although this is for much thicker wire. Okay, so wrong with my soldering iron, but it doesn't matter. So this one is this is our ground. Here we need one more for this one. think I need a new tip for my soldering iron, but that's a problem for another day. Okay, so this is it. That's our panel, wired. So you have one ground, this white one, that's gonna go to our Arduino, and the rest are all the digital inputs. So you have to, it's gonna be difficult to remember. So what I did is I made a little spreadsheet on Excel. So this is a pin number and functions. So you always try to write down the functions so you can know how to program them into your MobiFlight. So let's say this is our panel. It doesn't really make sense, but it doesn't matter. This is again just for the showcase. We need a pen. We need an Arduino. So the Arduino board, this one in particular has 13 digital pins and it has 5 analog pins, but the 2 pins on the bottom here, pin 1 and pin 0, you don't use it because MobiFlight doesn't support them. Those are some connection pins, it doesn't matter, so don't use those. Use the ones from 2 till 13. Basically you could also use the analog pins, but try not to. I mean, they should work probably, but again, you try to use the digital ones. The Arduino Mega has around 53, I think, inputs, so that's more than enough. You can even combine 2 or 3 panels on the same board. That's all okay. So basically what we then do is we find the corresponding pin. Again, we placed this button on a completely wrong. Normally there should be a 3-way switch here because there are, or actually 2-way, it doesn't matter, but this is just for the showcase. So we are gonna put this on pin number 2, and we are gonna write down PVS so that we know what it is when we start doing our MobiFlight thingy. So here we have, it's also, it doesn't matter. So master 2, one is on number 3, master 2, second position is on pin 4. Then we have this is VTHSIS is on pin 5. Then here we have our master 1. again, none of this makes sense, but this is just for me so that I know what is where when you start programming it in MobiFlight. But for you, you're probably gonna make a panel that makes sense, and then you're gonna say, okay, so master one on position, and then you put this, or let's say weather system position 1, position 2. You're gonna make it so that it makes sense for each switch. And these 3 are, so the black one is ignition, mode, it's on number 7. The purple one should be normal, it's on pin 8, and the last one is crank, it's on pin 9. So there you have it. Basically, oh yeah, right, sure, sorry. And then the last ground pin that we took from one of the switches. So again, you connect all the grounds to each other and then leave one more line for your Arduino. And here you see the GND. Well, GND is the second one and third one on this line here. So you put, and that's it. That's the whole panel wired up. Again, it doesn't look pretty, it's very chaotic, but it's gonna work. So now we can go to the programming part.
Okay, so let's get to the programming part of our video. We have here our MobiFlight app. So first we have to connect our Arduino, take the cable, connect it. Try not to connect it to your hub if you have one because of the power supply. Try to connect it directly to your PC motherboard, or if you have a USB hub that's with its own power supply. So here it says that it has found a board that is compatible. It's going to automatically open your MobiFlight modules tab. You see here it says compatible board. Right click on it, update firmware. We know that it's an Uno. Give him a moment to complete the update. Okay, successful. Also, before you start, go here to the extras tab. Hop, that's a website where people upload their own presets for the planes, for most of the planes, or maybe all of them. So you're gonna need that stuff. Just do the update, back to the MobiFlight module panel or tab, right click on the board you have, add button. So we said here, what was it? Let's start, for example, with this thing. It's our master 1. That is pin number 6. Master 1 on. Okay. Add, right click, add button. We have the second one. In this one we are gonna make it overhead bat 1, battery 1, for example. Next one, this thing here, we are gonna make ADRs 1 off, I forgot which one was the... That's number 5 pin on our spreadsheet that we did before, so that you know which cable goes where. 8 years, 1 off. We said that this thing is 9. Add device buttons. 8 years, 1 nav. Right click, device button. Oh, I forgot again. That's pin number 8. Right click, add device. This is 8 years, 1 at. That's pin number 7. Okay, add device button. That's for PVS. PVS is pin number 2. Pin number 2, let's say that's gonna be our takeoff config button or an ECAM. And I think that's about it. This one we don't need. Right click, remove device. When you're finished with your device assignments, upload config, press OK, give it a second, upload finished, OK. So when we are done with that, here we have output configs and input configs. Output configs, that's for your LEDs or your, how do you say it, 7-segment displays for TCAS or for your radio panel. But we are going to go to the input configs. You press here, double click. We said master 1, not 11, 1 on. Next one we did overhead bat 1. Then we did a deer 1 off. ADRs 1 nav. ADRs alla. ADRs 1 at. And then we did takeoff config. Okay, so we have our inputs assigned. So master 1 on, you go here to edit, module, MobiFlight Uno, device, master 1 on, action type, Microsoft Flight Simulator, vendor Phoenix. You see here you have a lot of planes you can, how do you say it, configure, but for this thing we're gonna do Phoenix, aircraft A320, system. What was this? Engines, select preset, engine, toggle engine master 1 off. You can copy this whole thing, it's much easier, you don't have to do it again, just paste it. And then switch off. So this is a different type of input. So there is a press, release, you can hold the button all along, release, but we're going to use these two. So on press it's gonna put the master switch on release it's gonna put the master switch off. And okay, that's that one. Overheads, so the same thing, MobiFlight Uno, overhead battery 1, Microsoft Flight Simulator, Phoenix A320 system. What was this? This was, where is it? Electrical. Ooh, these are all breaker switches. Overhead battery 1 on. It says here even somebody already, because this is mostly community made, so somebody already wrote it intended for the latching switch type, and that's the one we have. So we're gonna do that. Copy, on release, paste, same thing, just off, and okay. Next one we have 8 years off, and then again the same procedure. Our device is 8 years on release, 8 years actually on press. We're gonna put our nab into off. We don't need the release option because this is a three-way switch. So okay, ideas one nav, MobiFlight Tuno, ideas one nav. I forgot to copy the thing, but it's okay. 8 years, one knob, nav, copy, okay. This one, it's gonna be the same thing, 8 years and paste. 8 years, one knob, at, okay. And this one is takeoff configuration. That should be on the Ecam tab. Takeoff config button, press, copy it, on release, paste it. Okay. So I think that should be it. Run your MobiFlight. Let's get into our sim. This is for our engine. This is for our battery switch. Here we have our 8 years switch. And the last one we did was our takeoff config switch. And that's it. That's how you do it. Basically, again, we just made this panel. It doesn't make any sense, so it's a waste, but you can apply the same principle to any panel you make. Just the only thing that is different is the alignment or positioning of your switches. I'm gonna put all the files of the panels I made to the description of the video, so you can copy my design or you can adjust it by your needs. You can do whatever you want, but the principle is basically the same for all of them. So if you have any questions, feel free to ask. I'll try to answer them as best I can. Again, if this video is confusing or I went too fast, or I'm sorry, I don't usually do these things much or actually at all. And yeah, that would be it. Thank you everybody and take care. Bye bye.